Let's convert these number of resistance into single value, because in the numerical we have to convert a number of resistance into equivalent resistance, means one single value. For this we have to attach ammeter and voltmeter at appropriate places. Here I am attaching only one ammeter on the series side because the current value is same in the series, and 3 voltmeters on each resistance because each resistance experience different potential difference. And on the parallel side I am attaching only 1 voltmeter because each resistance experience the same potential difference, and 3 ammeters in order to see the different current values, because in the parallel the current is divided into number of groups according to the number of resistance. So let's make the formula of resistance or equivalent resistance for series. Here we have a battery in which one terminal is connected to positive side and one terminal is connected to negative side. The electrons are moving from negative to positive and current is moving from positive to negative. So the potential difference created by a battery is nothing but the values given by the voltmeter, that is V1, V2 and V3. So whole potential difference is nothing but the sum of the potential difference in each resistance. So V is equals to V1 plus V2 plus V3. Here V is nothing we get from the Ohm's law, that is V is equals to IR. So replace the V with IRS because RS is nothing but an equivalent resistance in series. Here V1 is nothing but the current in one resistance and resistance value, that is IR1. Why I am not writing I1? Because the current value is same. V2 we get IR2 and V3 we get IR3. After taking the common, that is I is common, and cancelling from left and right side, we get RS is equals to R1 plus R2 plus R3. For 3 resistance, if we find the equivalent resistance, we just add the resistance, and for the n resistance we get the formula, that is RS is equals to R1 plus R2 plus R3 and so on up to Rn. Let's find the equivalent resistance in case of a parallel circuit. Here we attach a battery in which electrons are moving from negative to positive terminal and current is moving from positive to negative terminal. Here I am taking I current is moving from positive to negative terminal. On the junction, the current is divided into 3 parts, that is I1, I2 and I3. These current readings are found by the ammeters A1, A2 and A3. So we can say that current I is nothing but a sum of I1 plus I2 plus I3. From the Ohm's law, V is equals to IR, it means I is equals to V upon R. Now put the values of I, that is V upon R. In the I is replaced with V upon Rp. Here P is nothing but an equivalent resistance in parallel. Here I1 is replaced with V upon R1. Why I am not writing V1? Because potential difference is same in each case. I2 become V upon R2 and I3 become V upon R3. Taking the V as common and cancel from left and right side, we get 1 upon Rp is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. This is the equivalent resistance we get for the parallel. If the circuits, or we can say that if the resistance are n numbers, then we get the formula 1 upon Rp is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3 plus so on up to 1 upon Rn.